Today we are doing section 3.3. It is going to look and sound very familiar for those of you that were here for 3.2. We are going to use angle relationships to prove that lines are parallel. So yesterday we started with parallel lines, and therefore we knew certain things about the angles. Today we are going to start with the angles and decide if lines are parallel or not. So it'll seem very similar. All right, on number 1, how do we know that those lines are parallel already? The triangles on them. So if we're trying to find the value of x, what's my equation? Ataya? Good. Can anyone tell me why Ataya set them equal to each other? Why? Akira? That's the kind of answer I'm looking for, but that's not the relationship. What is it, John? Corresponding. So those angles are corresponding on parallel lines, therefore they are congruent. And to solve it, we would need to subtract x equals 32. Okay, so you have to be able to identify the relationship and know what it means. So corresponding angles would be congruent on parallel lines. Write the converse of, if it is raining, then Josh needs an umbrella. Anybody remember how to make a converse? Deidreana?
If it's not raining, then Josh doesn't need it.
That is the inverse. Deidreana? Good. The converse is when we just switch them. The inverse and contrapositive bring in the word not. So if Josh needs an umbrella, then it is raining. Questions on our warm-ups? Okay. Anybody need more time? We're moving on. All right, the converse of the theorems and postulates we learned about in section 3.2 are also true. So this is what we did yesterday, but we're switching it around. So again, we're going to have these diagrams. We're going to fill them in with angles, name our lines, and talk about the if-then form with symbols. So the first one, if corresponding angles are congruent, then the lines are parallel. So notice that I did not put any triangles on the lines because I don't know that they're parallel right away. I'm going to call them M and N today. So if I were to have a pair of corresponding angles like 1 and 5, I could say that if angle 1 is congruent to angle 5, then M is going to be parallel to N. The converse of what we did yesterday. We're just flipping them around. The second one, if alternate interior angles are congruent, then the lines are parallel. So again, I'll call them M and N. Alternate interior. We'll use angles 4 and 5. So if angle 4 is congruent to angle 5, then M is parallel to N. All right, on the next one, if alternate exterior angles are congruent, then the lines are parallel. So if angle 1 is congruent to angle 8, then what do I know? If the angles are congruent, then the lines are Parallel. M is parallel to N again. All right, down at the very bottom, again, we would have those same lines, M and N. This time we're looking at consecutive interior angles. So this time I'll look at angles 3 and 5. So I want angle 3 to be in here, angle 5 to be down here. Now this time I am not going to talk about 3 and 5 being congruent. I would need to talk about them being supplementary. So I'm going to take it up to the top where I've got a little more space up here. All the way up here. So if the measure of angle 3 plus the measure of angle 5 equals 180, then I know that M and N are parallel. And again, we didn't have to use angles 1 and 5 for corresponding. We could have used another pair of corresponding angles. Same with all the rest of them. There are other alternate interior, alternate exterior, and consecutive angles that we could have used to do these. All right, find the value of X that makes M parallel to N. So we're trying to force it to happen. If M is going to be parallel to N, what needs to be true about these angles that they have marked? They have to be equal to each other because they are corresponding. Okay, so we see that they're corresponding. We want them to be congruent so that M and N are parallel. So what's my equation? Good. 71 equals 2x plus 3. You could have put 2x plus 3 equals 71. Doesn't matter to me which way it goes. To solve it, what do I need to do? Subtract 3. And then, good, divide by 2. What do we get for x? 34 equals x, or x equals 34. Does not matter to me if you write it forwards or backwards. Find the value of x that makes A parallel to B. So we look at the angles they marked for us. What is their relationship? Corresponding. And if these lines are going to be parallel, we want corresponding angles to be equal or congruent. So our equation would be good. To solve it, we need to add 7, 5x equals 105, and then divide x equals 21. Figure out what the relationship is. Think about what that means for parallel lines. Anybody need more time or have questions on this slide? Okay. The transitive property of parallel line states if two lines are parallel to the same line, then they are parallel to each other. So that means we're going to need 3 lines. I'm going to call my lines X, Y, and Z. And I'm going to mark them with the triangles. All right, so if X is parallel to Y, because they each have one triangle on them. And y is parallel to z because they each have two triangles on them. Then what do you think I can conclude? X is parallel to z. Okay, it should remind you of the transitive property. If two lines are parallel to the same line, they are parallel to each other. Our favorite thing about geometry has returned. All right, given that the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees, we need to prove that A is parallel to B. What should I start off with? The given. Measure angle 1 plus measure angle 2 equals 180. That was given. So we could either go to our diagram next or think about what the given means to us. Doesn't really matter to me. What? What's supplementary? Why? Very good. So we could use that given information to say angle 1 and angle 2 are supplementary. Now what was said is that they equal 180, so they're supplementary. But what would our formal reason for that be? Definition of supplementary. Very good. That's what we use to know that. Okay, next I think we should look at the diagram and think about what else we know about angles 1 and 2. They're consecutive. From the diagram, we can tell that angles 1 and angles 2 are consecutive. That is purely from the diagram. So we can write that we assume that from the diagram. If we know that angles 1 and 2 are consecutive and they're supplementary, what does that tell us? They're not equal to each other. Consecutive angles are supplementary. What does that tell us about our lines? They're parallel. So we can go to our proof statement now. So we can say that A is parallel to B. There are a couple ways we could say this. This would be the converse of the consecutive interior angles theorem from yesterday. If you were to just say consecutive angles supplementary, that would be fine for me. Consecutive angles are supplementary. If you want to get really formal and talk about how it's the converse of the consecutive angles theorem that we talked about yesterday, that's fine. But if you just say consecutive angles are supplementary, that's how I knew that the lines had to be parallel. That works. All right, another proof. This time they started us off with a couple givens. So again, you can list them together, you can list them separate. I personally like listing my givens together. We're told that A is parallel to B. We are told that angle 1 is congruent to angle 3. All of that was given. If you want to mark your diagram with what they gave you, that might help. So if you want to put your triangles on A and B to show that those are parallel, if you want to mark that angles 1 and 3 are congruent, you could do that. All right, so let's think about what we know here. Anything popping out at you that you think we know so far?
Exterior.
2 and 3 are alternate exterior, and we will have to use that eventually. But I would focus on the lines we already know are parallel first.
Okay, so
What do you think, Sydney?
Angle 1 and 2 are corresponding.
Good. So in this case, I don't even think you need to make that statement on its own yet. We could make the statement that angles 1 and 2 are corresponding. I don't think we need to. What can we already say about them? They're congruent because they're corresponding. If you made a statement saying angles 1 and 2 are corresponding, that's okay. I don't know that I would require that because that's part of our reason. Angle 1 is congruent to angle 2 because they're corresponding on what type of lines? Parallel lines. So you do need to say that. Corresponding on parallel lines, that is how we know that they are congruent to each other. Okay, so we could go ahead and mark that if we're going to state it. Now what do you think we could say? Bless you. Bless you. Good, we could say that angles, I think somebody said it, 2 and 3 are congruent to each other. I would take a couple different reasons for this. What do you think one of them is? That I would not take. I would take transitive, or I would take substitution. Okay, we, in a sense, should have flipped this one around, but I'll be a little generous on that. But if we had instead just said angle 2 is congruent to angle 1 here, it would be extra obvious. One's our middleman. We can cut them out. So transitive or substitution would work here. We can't say it because of alternate exterior because we don't know that X and Y are parallel. Okay, we would have needed X and Y to already be parallel to use alternate exterior. We are, however, going to use the fact that they're alternate exterior in the other way. So here I would say we do need to say angles 2 and angle 3 are alternate exterior. That is from the diagram. And now because of that, what can we say about X and Y? They're parallel. So now it can go the other way and we can say X is parallel to Y because alternate exterior angles were congruent. Again, if you want to put converse of alternate exterior angles theorem, that's fine.